Alright, so with cosine xy plus x cubed equals y cubed, then what you're going to have is a function, okay, with some stuff in it. Here's the junk. And then you've got a couple of other little pieces by themselves. So what we want to try and do is get dy dx all by itself. So that would be, what we're looking for is dy dx equals. This is what we're trying to find. So when we do this, when we take the derivative of both sides, we're going to ddx both sides. Then on the left, the derivative of cosine is negative sine. And you still have junk in there. Junk doesn't leave yet. So we're still negative sine xy. But we have to chain it because now what we want to do is take the derivative of the junk. And the junk is multiplying. Okay? So since the junk is multiplying, we got to follow our product rule. If I have u times v, and I take the derivative of this, then I get u times v prime plus u prime times v, or the other order of that. So what we've got then is going to be 1 times y plus x times the derivative of y, and the derivative of y is dy dx. Dy dx. If you prefer y prime, that's no problem. Then plus 3x squared equals 3y squared dy dx. Remember, we have to account for the derivative of y. Anytime we take the derivative of y, we've got to account for that guy. All right? So now, clean it all up. I'm going to have negative y sine xy plus, actually minus x sine xy dy dx plus 3x squared equals 3y squared dy dx. Okay, now here's the deal. All that happened was distribution in the front, yes. And so on this part then, what we're going to do is we want to get these guys together on the same side of the equation. And so to get these guys together on the same side of the equation, one of them has to move. And it doesn't matter which one moves. Just one of these dudes has got to change sides. I think it's easier for this particular problem to just add x sine xy dx to both sides. Because there's less stuff that has to move later. Now what's left on the left is negative y sine xy. Okay? And then let's move over this, plus 3x squared. He's okay, plus 3x squared. And that equals 3y squared dx dy, sorry, dy dx, plus x sine xy dy dx. Now the whole goal is to get these two turkeys all by themselves. Okay? And so since that's what you have on the right-hand side all by themselves, then we can actually factor those guys out. And we're going to end up with dy dx in the front. And then inside the parentheses will be 3y squared plus x sine xy. And that's still equal. Now the left-hand side, it doesn't change because we're done messing with it. So I've got minus y sine xy plus 3x squared. And then to finish Divide everything by this dude right here. Divide by 3y squared plus x sine xy. So this guy right here is your final answer. So it's not horrible, but there are a few steps you've got to pay attention to. Okay? Okay, so here's another problem that we can look at, and it's taking the derivative of the arc sine of 4x cubed. So in this case, we're going to let u equal 4x cubed. So du dx is 12x squared. And if I know what my u is, then I can use my formula. And if I can use my formula, life gets a whole lot easier. So when I do that, I'm going to end up with dy dx equals 1 over square root of 1 minus u squared. Well, u squared in this case is going to be 4x cubed squared times du dx, which is 12x squared. So go ahead and clean this up just a little bit. And you end up with 12x squared over 1 over the square root of, yikes, 1 minus 16x to the 6th. And then on the top, you're going to have 12x squared. And that's all there is to it. Alright, on this guy, what we've got is a logarithm. This is going to be a log base 10. It's an understood 10, so we don't write it down. And what we're going to do is we're going to follow our rule for derivative of log. And it looks like this. So we need to let our u equal 5x minus 8 and let a equal 10. The derivative of u is just 5. So then we take the dy dx on both sides. Then we're going to have dy dx equals 1 over u 5x plus 8, 5x minus 8, times the natural log of 10, times the derivative. And the only cleanup you would do on this is go ahead and multiply your numerators together. And that's all there is to it. Okay, on this guy, what we're going to do is take a little trick, a little rule of algebra, and we're going to take the natural log of both sides. And this gets us the natural log of y equals the natural log of 8 to the 4x. And this isn't too bad because we can use our properties of logarithms, and we end up with natural log of 8 times 4x. So now when I take derivative on both sides, on the left, I have 1 over y dy dx. Gotta have the chain rule. On the right, this is a constant, so it's just the derivative of the first times the natural log of 8. Multiply both sides by y. Again, algebraic correctness. And I have dy over dx equals 4y natural log of 8. But looky here. Y is equal to 8 to the 4x power. So my final answer becomes dy dx equals 4 natural log 8 times 8 to the 4x. So what looks like a really difficult problem is not too bad.